And just a quick plug, we're hiring, so if anybody's interested, hit me up and I can give you some details. And so the talk today is about Project Jupyter. Is anyone familiar with Project Jupyter? Know what it is? Is anyone familiar with it outside, or in its previous name, ipython notebooks? Yes? And you know that it is now kind of expanded beyond that, and you can run these notebooks in with other languages. And so what I want to hit on today is kind of give an overview of what the notebooks are, and then sort of try to keep it as broad as possible. I'm more familiar with Python, so a lot of this will be sort of Python-centric, but I will talk about the possibility of other languages. Let's just jump right in. Originally, Project Jupyter, like I said, was originally called ipython notebook. For those of you who don't come from a Python background, how many Python people are here? Not as well represented as it should be, but okay. So ipython is a different interpreter for Python. So it's like a REPL, right? So the Python command line interpreter is functional and not really very nice beyond that. ipython makes it quite a bit better as they were iterating through and improving the ipython REPL. One of the things they decided to do was they looked to Mathematica notebooks, and I'm not sure if anyone works with Mathematica, I never have, but they looked to Mathematica notebooks as an inspiration, and what they wanted to build was a front end that is web-based or browser-based for the ipython kernel. So that's how this originally started, and over the last year or so, it's migrated to a broader project that they renamed Jupyter. So it was originally implemented as a way of doing interactive scientific computing. It is really heavily used in the scientific community. Python's really well loved there, I think largely because a lot of the science packages were created by physicists who came to Python and was like, yeah, we can totally use this like easily to do what we need to do. So you see it used a lot in scientific computing. And its core use is for collaboration between researchers. And I'll show you a little bit later on how it is really, really great for collaboration. Probably just one of the best tools around for collaboration. Some of the handy features, and as we get a little later on, I'll do a demo and we'll be able to see what those features are. See them in action, but cell-based execution. So you can sort of isolate your code in a cell in the browser and like, I just want to run this. Now I just want to run this part. And yet all of that runs inside the same runtime. So if you do have code that creates state in one cell, it is automatically available for the next cell. So you can isolate your code, but it can still run together. You can store notes in Markdown, in LaTeX, you can store images, you can store videos. This is where the collaborative part of it comes in. It's really handy to just pass these things around and give someone like, here's everything I've done. You can look at it, you can work with it, whatever. You can actually save the code output, and you'll see that a little later on too, which is great because if you have some long-running bit of code and it's created some output for you, the ipython notebook will save that output so you can just pass that along and say like, here's my code, you don't have to rerun it, here's the output for it. And so everything is just wrapped up right there in a handy little package. And then you can convert to other formats such as HTML and PDF if you need to hand some stuff off. And of course you can share the notebook files themselves because they are just JSON files. That you can store up and pass around. They actually have, like, GitHub integration for ipython notebooks is really top-notch. If you may have ever gone out to a GitHub repo and seen that someone has a notebook in there, you click on that file and it's, you know, it parses the whole notebook for you. It's really nice. There's also a website maintained called MBView, I believe, viewer. sorry, that where you can put your notebooks up and host them, and it actually has a Python backend to run your notebooks for you. So, that's another way that you can collaborate if you can't directly send a notebook to someone. So let's talk about the architecture. So the architecture is, we talked very briefly about what the front end can do. There are actually multiple front ends we'll see here in just a moment. Specifically for ipython, as it started out, you can see here, there's that blue dot in the middle that is the Python execution. The terminal ipython, which is where this all started, and the ipython kernel, which they're two separate pieces of software, they share that Python executable right there in the middle, right? So you can log into ipython completely unrelated to the notebooks or any of the other front ends, just log into ipython, and it shares the same executable space as if you were to log into the anything that uses the kernel itself. And this is sort of how the backend is set up. You have some type of executable for your particular language, and then you create a kernel around that to communicate with the front ends. You can see that the kernel communicates through 0MQ message passing, and we'll see a little bit later on. We'll dive a little bit into how that happens, not too detailed. But essentially, this is the kind of setup that you would need to establish for your own, like if you were to create a kernel for your own language, you would need to, you don't have to have the terminal ipython portion of it, but you definitely have to have some executable and then some sort of kernel wrapper to communicate between that executable and the front end along the 0MQ message passing. So, like I said, there are other kernels. Currently, Project Jupyter maintains 3 kernels, iHaskell, IR, and iJulia, but there are tons of community kernels that are available for Node.js and C++ and Clojure, and there are 40-something odd kernels out there. So this is where Jupyter is really starting to expand, because it's really such a great tool to use. There's any kind of even halfway popular language, there's going to be a kernel already made for it. And if there's not, then the instructions on making your own kernel are out there. We won't go into detail in that, because each kernel is most likely language specific. So to actually set up your execution environment is beyond the scope of this, but it's definitely possible. It's easily-ish done to create a kernel for whatever language you want, so that you can tie into these various front ends, and especially the notebook. And so for the other kernels, there are actually 2 different ways that you can make a kernel. So you can have a wrapper kernel, which if the language you're interested in has good Python wrappers, then writing a wrapper kernel lets you reuse the Python communications, so the Python message passing, so you don't have to re-implement any of the 0MQ machinery. You just have to implement the language execution. It's probably a very small number of languages where that's actually the case. More than likely, the kernel is going to be a native kernel, where you have to create the execution environment and all of the message passing machinery, which all of that stuff is really well documented. They've done a really good job, and they're really actively working to try and improve their documentation so that you can really get a fairly straightforward sense of how to implement this in whatever language you want. So if you're writing a new language and you want to write a kernel for it, then you can do that along the way. Like I said, there are various front ends where specifically the notebook is probably the most popular front end, especially for anything outside of Python. But there's just a straight command line kernel, or straight command line front end for it, which looks exactly like if you're using ipython, it looks exactly like the ipython interpreter, although technically they are separate pieces of functionality. There's a Qt console, which just pops you up a fairly stripped down little window in whatever OS environment you're in. So it'll let you run and execute code in some little pop-up if you, for whatever reason, don't like using the command line. And then, of course, there's the notebooks. And you can write whatever kind of front end you might possibly want. So, you know, again, it's all just message passing. So you could write up whatever kind of front end you needed. If you needed something on an iPhone or whatnot, I assume it's completely feasible to write something that will pass messages along back to the kernels. So it's very flexible as far as that goes. Now for the notebooks themselves, things are just slightly different. As you can see here, the user interacts with the browser, and instead of the browser talking directly to the kernel, the browser talks to this notebook server that sits right in the middle. And the server itself talks both to the kernel and to the notebook file. So that lets the notebook server save out all the information, do all the things that it needs to do that make the notebook much more flexible than any of the other front ends, and yet it still talks to the kernel to do all the execution, code completion if you have that built into your kernel, just whatever the kernel needs to do, the notebook server talks to the kernel as opposed to the browser doing it directly. The browser just renders everything that comes back from the kernel and from that notebook file. And like I said, it's all message passing between the kernel and whatever front end. It communicates along 0MQ sockets. There are 5 different types of sockets that you would have to account for if you're going to build your own kernel. A shell socket. The kernel should be able to allow multiple front ends to attach to it at the same time. And so the shell kernel communicates that. That's where it does the code, it asks for code completion and execution and all of that kind of day-to-day, requests that go out to the kernel. There's a command socket, which is sort of like a priority message queue, so that it lets the kernel, those types of commands can kind of skip line. They don't have to queue up behind regular shell commands. So if you need to stop the kernel or reboot it or whatever, those types of things go on their own socket so that they can execute more quickly. There's the IO pub socket, broadcast channel. It publishes all the side effects, like standard error, standard out, that type of thing. It publishes it to multiple front ends at the same time. This sort of lets all the different front ends that might be attached know what's going on, so they can sort of keep track of each other. And then there's the standard in, which operates separately from the IO pub. It's where especially like in Python, if you were to ask, if you had code execution that asks for the user to interface with the running execution, you would use either raw input or input command, and that's where those inputs directly into the kernel would come from this standard in socket. So that was sort of a really quick run through of the high-level architecture and of this. Are there any questions about anything so far? I feel like I've kind of gone through kind of quickly. We're going to go through a demo, and maybe some of this will sink in better. But anything so far? Okay. Let's demo. So we're going to start off here. When you start the new, I can't type and talk at the same time. So when you start, when you want to start up a notebook, you can use the old ipython notebook command, but now they're trying to move everybody over to the Jupyter command. It's just something that you install. They're really straightforward instructions on how to install Jupyter in any environment. But in any case, you start it all up. Is that better? Better? Good? All right. Yeah, so if you miss it, it's just Jupyter Notebook is the command that you would use to launch. And it starts the kernel and then starts the notebook server. When you call notebook, it starts the notebook server. And what you end up with is essentially this. Now, this is, it looks in whatever directory you start the notebook server from. So I keep all of my notebooks, or try to keep them all in one directory, just so that I can have easy access. It will read from the directory it starts in down, but I haven't figured out how to get it to go up and browse around outside of its own root directory. So I keep everything all together in one place. This is a list of the notebooks that it's found. It actually has a list of like all the files it finds, but it prioritizes all the notebooks first. So these are all different notebooks that I've created for different parts of projects that I've had to work on and that type of thing. So all you have to do is pick a notebook, click on it. The server starts running that notebook, and then you get whatever's in there. Like I said earlier, this will take, this is Markdown. Actually, I think technically that's HTML. That's Markdown. You can see it's just, it even does GitHub flavored Markdown and LaTeX right there. So if you need to put, if you need to actually start putting some type of LaTeX, especially for mathematical symbols and that type of thing, just shove it in there and it interprets it, and everything's really good to go. You can see here, this is regular Python code. It's just, that's calling out to one of our endpoints that I have running locally on my machine and grabbing some information and spitting it out. The thing that makes this so usable or so easy to pass information around, though, is underneath. So like this is the cell. Underneath the cell right there, that's the output from the last time I ran this before I restarted the server. So I ran this, closed the server down completely. It saves the state in the JSON file. And then when I launch this back up, if I already had my output there, it's already there. So I don't have to rerun this command. If this were a long-running command, like I said earlier, then my output's already there. I can show somebody, here you go. This is what I've already done, and then you can work on it interactively if you need to or whatnot. Adding new fields, like I said, right here, I actually had, since the output's already there, but this, for instance, this import statement, if I were to try to use that right now, it doesn't know anything about it. Request is not defined because while this is, the state is saved, it doesn't actually run the code until you tell it run the code. Wait. Should have not done it that way. I may not have my local server running. There we go. So now it doesn't complain because I did the import separately, and it knows about the request library, which, if you're not familiar with Python, that's just the library for hitting websites. And once that's imported and it's usable in any of the cells, like I said, I can do it here. I thought, not working here for me. Yeah, probably so. There we go. Let's ignore that for a moment. But it does give you nice, pretty stack traces. So you have all that sort of Python machinery built in if you mess something up, like I clearly just did. There we go. So it has code completion, right? So all these nice little features that you would expect inside a well functioning REPL, so that you can get in here and like kind of easily start just coding away. It has another great feature, which is, so if you're not familiar with ipython has these magic functions. They usually start with a %, and it will do code completion. It will do completion for that, and then it actually loads the file. So you can go in, if you have something a file that you've already been working on, you can load it up into the REPL and kind of play around with it here without having to, use it in whatever other environment. Someone just sends you a file. You can pull it in here and play around with it. You'll notice it actually then, as soon as it loads the file, it comments out the load command, so that if you go in here and start running this bit of code, it doesn't try to reload the load command. There's an equivalent save command, so you can go in here if you make any changes and you just want to save them back to the original file, it will do that. Otherwise, it only saves it any changes into the JSON ipython notebook file itself. Running code is really simple. You're in there. You just hit. You can hit Shift Return. Got to do my imports again. Sorry, not as well prepared for this as apparently I should have been. Thought I had that. Anyway, yeah. So this is one of the problems that you might occasionally run into. You have to have any kind of packages installed in whatever environment that you're running your ipython in. So I run this in a virtual environment. If you're not familiar, if you're more familiar with Ruby does virtual environments. A couple of other languages do also. But if you don't have this like Faker library installed in whatever virtual environment you start your notebook in, then you got to shut down your notebook, install it in that environment, restart your notebook so that it knows all about it, and then you'll have access to it. But so yeah, these are some of the things that you can do. Like I said, just pull in the code, run it, get your output. It is just an IPB. What's the file? Sorry. Get the file extension here in a second. They are IPYNB files. So again, that's just a JSON file. Right. So it's just a pretty standard JSON file that it keeps track of the entire state of your notebook at that time. So you could go in there and mess around with it if you needed to, but probably not the best idea. While I'm here, I'll show you. Couldn't get my Qt console to work, but let's go back over here. So these were notebooks I already had created. You can create new notebooks if you need to for whatever projects. And then if you have other kernels already installed, you can create notebooks that are specific to that kernel. You can even have, if you're familiar with Python, there's Python 2 and Python 3. You can have those both in the same virtual environment so that you could start either a Python 2 or a Python 3 kernel. You can start a Node.js kernel here. So it will do Node-y type stuff. I am not much of a node person, so extent of what I've got. Right, so you can run, so it's clearly running node code as opposed to Python code. So again, for any of the kernels you need, you can do that. You can also, if you don't want to go into a notebook, if you don't, if you're just at the command line and you're perfectly happy doing that, you can Jupyter. So and so it defaults to running the ipython kernel, right? So this is your, ipython code or regular Python code. But you can also do this. And now you can run node inside here, which you probably already have a node command line, but the console for this is actually quite a bit better. If you have multi-line code, which, let's see if I can fake something real fast. Somebody help me out here. So not what I wanted to do. Do it this way. And thus we see the problem with live coding. Not helped by the fact that I don't type very well at all. Right, so in the original Python interpreter, if I wanted to go back through and edit this code, I'd have to go up. If I wanted to rename the function, for instance, I'd have to go up twice because it's only going to go back in history one line at a time. This actually goes back in history for the entire, like, whatever indentation level I just created or whatever function I just created or whatnot, so that I can then go through and have access to the entire thing without having to go up. Like if this is 8 or 9 lines long, you don't want to have to go back 8 or 9 lines and then like hit enter 8 or 9 different times to get all the different stuff back in line. This just brings it all back to you like all together. And it should do that for pretty much any kernel that that gets created. Now, one of the things that I found out was like when I did this load right here and loaded the file in, like I said, that is magic. Those are magic functions inside the ipython kernel. Apparently no one has implemented them for the node kernel. Because it doesn't know what the line magic load is. Now there are magic functions implemented for the node. Again, not really much of a node developer, so I'm not familiar with exactly what all they do. So it's possible that someone can implement this same type of behavior as a magic function, just no one has. And I really don't know why. That seems pretty like something you'd want to do pretty straight off. In any case, yeah, so that's kind of a whirlwind tour of Jupyter, Project Jupyter, some of the things you can do with it, and some of the ways that you can store and save information. If anybody was here a couple of weeks ago when they did, when they were talking about the salary survey that they did, and you saw Tim do his bit near the end, he had a lot of stuff inside an ipython notebook, and I think he was pulling it straight off his GitHub, and so that's the kind of thing that's really easy to put a lot of information together and easily share it with other people. IPython has a lot of great integration for the scientific and graphing and data analysis. And as soon as someone writes that for other kernels, then other kernels will have that functionality too. So yeah, that's sort of what I've got. I will end with an unknown line magic error. Are there any questions? Yeah. Mm-hmm. Right, right. So the question was, what projects have I used this for at work? None, sorry. I would love to, like, I want to try and sort of spread the word about this a little more at work. I use this on an almost daily basis for my own personal, just to like work out little algorithms, that type of thing, where it's so much easier than going in and, you know, like running the code that I have, you know, in a microservice even, you know. But as far as using it at work, for what it's really I guess for what we do specifically, it's probably not as usable on that front, except to prototype and then send that off to somebody else and be like, okay, so you can run this very quickly. I use this a lot to, like, if I have to bring in files that typically read from an environmental, you know, from a configuration file, I'll fake out the configuration file in one cell, bring the actual running code in, and that way I don't have to start it with the configs. I can change my configs very quickly and see what sort of different results I get or that type of thing. I have no doubt that there are uses for it in the workplace, depending on what work you do. I haven't seen it, you know, that much day to day for what I do, other than, you know, using it as sort of a persistent REPL, more or less, and then possibly being able to pass it around. There's, you know, you have to be able to install Jupyter and whatnot. So if you're going to pass these files around, whoever gets the file has to have that environment, you know, to be able to run them. If everybody's on the same, you know, if everybody's using the same language or languages, that probably shouldn't be a problem to do. But yeah. Yes, you can view the notebooks because it is just a JSON file. You can certainly view it through, like I said, through GitHub. GitHub does great with it. That's a really good question, and I am not entirely, completely 100% sure that's the right answer, that you can view the notebook. Does anyone who's used notebooks know for sure? Yeah, right, yeah. Right, and I thought I did read that you could. Right, yeah. Yeah, so it's possible at some level. Yes? Mm-hmm. So the question was, earlier I had a slide that said that multiple front ends could connect to the same kernel. Have I ever done that for code collaboration? I have not. Totally you could though. Yes, that's absolutely something that, you know, you can hit this across networks, that type of thing. So it does not have to just run locally. So yes, you could totally use this for code collaboration. I don't know how it would handle conflicts with people in the same cells, you know, at the same time. I'm sure it has a way of working that out. I've just never seen that mechanism in action. But yeah, you could. Any other questions? Awesome. All right. I hope you guys enjoyed it. Check this out. It's a really great tool.
Thanks, Derek. And I guess see everybody next week. And we're always looking for speakers. So if you have something you want to talk about or you'd like for someone else to talk about, let us know, and we'll try to match those things up. So.